Hello students, welcome to Talk on Civil Engineering. Let us see one more question from pre-stressed concrete losses. So here we have a question related to a post-tension member. So he is asking to calculate what is the percentage of total loss, in this post-tension beam. Okay, so here he has given the cross section of beam. It is a rectangular beam of 200 mm wide and 300 mm deep, and the area of wires is given. And initial pre-stress in the wires is also given, that is 1200 Newton per mm square. And the span is 12 meters. And the rest of the required data he has given. The more important is the tendon is a parabolic tendon. Okay. So, and it is having eccentricity of 100 mm at the center and 0 at the support. So it is something like this. So this is a central axis. So at the support, it is having 0 eccentricity, and at the center it is having 100 mm eccentricity, and at the support it is 0. So something like this. Okay, so now let us solve this problem. So we know for the post tension member, so we will be having the loss due to we'll be having 5 losses, that is loss due to creep, shrinkage, anchorage. So let me write here: loss due to creep, shrinkage, anchorage, slip, due to relaxation of steel, and fifth one that is due to the friction. Okay, so here we don't have the loss due to elastic shortening unless if the tendons are pre-stressed in stage wise. So if there are 3 or more cables are there are more number of cables are there, and these cables are pre-stressed in a stage wise, one after another, then you will have the loss due to elastic shortening as well. So here only one cable is provided, only one cable is provided, and there is no data related how the pre-stressing is done. So we'll take only these 5 losses. Okay, so now let us calculate the loss due to creep, loss of stress due to creep of concrete. Okay, so firstly, we know here he has given the creep coefficient, so we will be using the formula related to creep coefficient. Okay, so that is creep coefficient into FC into alpha E. Okay, so alpha E we can calculate. Here he has given the Young's modulus of steel and concrete values are given, so using this we can simply calculate alpha E, but the more important one is FC we need to calculate. Okay, because FC calculation of FC is just it is little tricky because it is a parabolic profile. So we need to take average FC, or else you can take maximum FC, but it is recommended to take average FC. So let us take the average FC for this question. So what is FC? So FC is a stress in concrete at the level of wires or the cable. So this thing you need to understand. So it is a stress at the level of wire. Okay, so here since it is a parabolic tendon, so the level will changes from support to the center. At the support, the level is from the axis, it is 0. At the center, from the axis, it is 100 mm, right? So therefore, let us find out FC at support and at center. Okay, so FC at support. So it will be direct stress itself, that is P divided by area of concrete. Okay, so what is P? So here he has not mentioned the pre-stressing force. So we need to find out what is the pre-stressing force. Okay, so P is equal to initial pre-stress into area of steel. Okay, so initial pre-stress it is 1200 as given in the question, and area of steel also he has mentioned in the question, that is 320 mm square. So it will be 384 kilonewtons. So this is a pre-stressing force. Okay, so 384 into 10 to the power of 3 divided by area of concrete, that is 200 into 300. Okay, so it will be 6.4 Newton per mm square, and this will be positive. Always the direct stress will be positive only. Okay, and we'll have only this direct stress because there is no eccentricity at the support, so that tendon is directly matching with the axis. right? So there will be no eccentricity. So therefore, we only have the direct stress. Now FC at center. Now here we'll have the direct stress, which will be always positive, P divided by area of concrete, and the stress due to the tendon profile, that is due to the eccentricity of the tendon, will have the stress as well. So that is moment of this tendon, moment of the pre-stressing force divided by I into Y. Okay, so this Y will be equal to the eccentricity E, because here we are finding the eccentricity at the level of, so we are finding the stress at the level of steel, right? So here my steel, the tendon is provided at the distance of 100. Okay, so Y is the distance where the tendon is from the central axis. Okay, so let us substitute the values. So P by AE, already we know this value, P by AC, so that is 6.4. Okay, so this P is 384 into 10 to the power of 3, E is 100, and I BD cube by 12, so 200 into 300 cube by 12, and E again 100. Okay, so if you calculate this, you'll get the value around 14.99 Newton per mm square. And again, this will be positive. Okay, so we got the FC value at support and at center. Now let us find out what is the average FC value. Okay, so FC average. So for this, let us draw the stress distribution diagram. So it looks something like this at the support. So this is support and this is center. So at support, so the value is 6.4, and at the center, so the center, the value is 14.9, right? Okay. So here this will be 6.4, and this will be 6.4, 14.9 minus 6.4, right? So it will be 8.5. Will be 8.5. So the average of stress, this 8.5, the average, the mean will lies somewhere here. Okay, so that is two-third of this 8.5, right? So FC average is equal to 6.4 plus 8.5 into 2 by, that is up, I mean, two-third of 8.5. Two-third of 8.5. So this will be the average. Okay. So this will be the FC average. Right. So let us put these values in calculator. You'll get the FC average has 12.1 Newton per mm square. Okay. So now let us calculate what is alpha E value, modular ratio, that is Young's modulus of steel divided by Young's modulus of concrete. So ES value he has given in the question has 210 into 10 to the power of 3, and EC, that is 32 into 10 to the power of 3. Okay, so it will be 6.6. Okay, now all the values we know, just directly calculate what is loss. So that is creep coefficient into FC average into alpha E. Okay, so creep coefficient he has given has 1.6. 1.6 into FC average, we got 12.1, and alpha E as 6.6. So it will be equal to 127.8 Newton per mm square. Okay. So now let us find out the loss due to shrinkage of concrete. Loss due to shrinkage of concrete. So we know the formula. It is ultimate shrinkage strain into Young's modulus of steel. Okay. So we need to know what is ultimate shrinkage strain. Did he is given any value? So here he has not mentioned the ultimate shrinkage strain. So therefore, we'll take from IS code. So IS 1343 is recommending for post tension member. So it is 200 into 10 to the power of minus 6. Okay. So ultimate shrinkage strain is equal to 200 into 10 to the power of minus 6 into ES value 210 into 10 to the power of 3. So it will be 42 Newton per mm square. Okay. So now let us find out the third loss, that is loss due to anchorage slip. Okay, so here the formula is modulus of steel into the anchorage slip divided by the span of the beam. Okay, so it is 210 into 10 to the power of 3. And what is the anchorage slip? So anchorage slip is 2 mm, and the span is 12 meters he has given in the question. So we need to substitute in mm, therefore multiply with 1000. So it will be 35 Newton per mm square. Okay, so now find out the fourth loss due to relaxation of stress in steel. Okay, so here in the question he has mentioned to take 3%. 3% has a relaxation of steel. Okay, so the 3% is of initial stress. 3% from initial pre-stress. Okay, so the 3% of loss equal to 3% of initial pre-stress. Okay, so that is 3 divided by 100. What is the initial pre-stress? So initial pre-stress is given has 1200 Newton per mm square, right? So into 1200 Newton per mm square. So it will be 36 Newton per mm square. Okay, so now let us find out the final loss, that is loss due to friction. Loss due to friction. So here it is a parabolic profile. So we need to calculate what is the alpha value. That is, we need to calculate the slope, right? So let us write the loss formula. Loss is equal to initial pre-stress mu into alpha plus k into x. Okay, new value has given in the question. It is 0.35. So alpha value we need to calculate. So this is the slope. The slope we need to calculate, right? So we know the slope alpha is equal to 2 times of alpha equal to 2 times of slope on both sides. So here, so this side on that side. So this will be 2 times of the slope, right? So 2 into slope we can calculate using 4e divided by L. So this using this formula we can calculate what is the slope or the inclination. So 2 into 4 times of eccentricity, that is 100, E is equal to 100, and L is 12 meters. So we need to substitute in mm. Okay, so this will be equal to 0.067. So this is in radians. Okay, 0.067. Yes, so now let us substitute the values. So loss due to friction is equal to P naught, it is 1200, and mu value it is 0.35. Coefficient of friction is 0.35, and alpha it is 0.067. 0.067, and k value he has not mentioned in the question. But we'll take the recommended value, that is, so the recommended k value is equal to k equal to 0.0015 per meter. Okay, so this k value is the wobble effect. So that is unexpected change in the cable profile will happen. So k we need to take either the slope is straight or you may have the slope or not, but k will be always there. Okay, so k value is 0.0015. So it is in per meter, and x is the distance or the span. So that is span is 12 meters. So here this meter get cancelled. So you no need to convert into mm. So it will be 49.7 Newton per mm square. Okay, now the total loss of pre-stress So the loss due to one creep. So due to creep, we got the loss of 127.8. So all these values are in Newton per mm square. And due to shrinkage, so it is 42. And due to anchorage slip, so we got the value around 35 Newton per mm square. and due to relaxation of steel, it is 36, and due to friction, so we got value around 49.7. So sum up all this. So total loss is equal to, so it is 290.5 Newton per mm square. Okay. So here in the question, he has to calculate the percentage of loss. The percentage of loss is equal to 290.5 divided by the initial stress, that is 1200 into 100. So it will be 24.2%. So there is a loss of 24.2% pre-stress in this post-tension beam. Okay. So this is how we are going to calculate for the post-tension beam member if the tendon profile is parabolic. Okay. Thank you all.